Now we are going to move on to dividing monomials, but before we get there, we're going to start with 8 over 16. Remember, 8 over 16 will simplify, and we can take an 8 out of both the top and the bottom, so that will give us 1/2. Now, when we're dividing monomials here, remember that we have 5 m's on the top here, if I can write them all out. And then we are dividing all of that by m times m times m. So now our m's, let's cancel some out. Top and bottom, top and bottom, top and bottom. So how many are we left with here? We are left with just a m squared. So now when our monomials are over each other in a fraction, what are we going to do with the 5 and the 3? Well, we will subtract them. So that leads us to our first rule. So when we are dividing powers, if we have numbers with exponents, this is just telling us that we are going to subtract our exponents of the same number. So let's try it again here on example number 3. We have x to the 4th and an x to the 2. So I'm going to rewrite it like they do here. x4 minus 2. I'm going to change my colors for y's. And we have 6 minus, division means minus with exponents, so it's going to be 6 minus 3. And so that gives us x to the 4 minus 2 is 2. Y, 6 minus 3 is 3. So all of this mess simplifies to x squared y cubed. Now if we jump down to 4, there can be numbers and letters. So 8/16 we did in our first example simplifies to 1 over 2. Now here we have the same example as we did up here. Simplifies to x squared on top, y cubed still on top. If we wanted to, we could rewrite this as x squared y cubed all over 2. And we would simplify that whole monomial. Next, we're going to be moving on to n cubed over n cubed. Well, let's write this out and take a look at, what we come out with. And that's supposed to be an n times another n all over n times n times n. So if we cancel out again from top to bottom, top and bottom, top and bottom, we cancel everything out. So what are we left with? We are left with 1. Well, what would be our exponent? We would subtract those 3's, right? We would have n to the 3rd minus 3. So we would have n to the 0. So what is n0? Anything to the 0 power is 1. So if we go to 1024 to the 0 power, anything to the 0 power would be 1. Now let's take a look at 0 to the mth over 0 to the mth. Here, again, we have 0, and I'm going to write this out just by definition of exponents, and that multiplying that will keep continue. And we have 0, same thing on the bottom, and that will continue. Well, we can cancel out, right? But what are we canceling out on the bottoms? We're canceling out zeros. 0 times 0 is 0. 0 times 0 is 0. So we would be dividing by 0. And can we divide by 0? No, we cannot. So that would leave us with a no solution. So we cannot have 0 to the 0 power. That is not allowed. Next, here we're going to simplify some other stuff, and I'm going to first write this out for us. So on top we have t times t times t times t over t times t times t times t times, I'm going to add a couple more here, times t times t. Now, 4 on top, 6 on the bottom. Let's start canceling out top and bottom. Gone, gone. Top, bottom, top, bottom, top, bottom. Missed it. Bottom. Extend this bar a little bit more. Now, how many are left on the bottom? There are 2 t's left on the bottom. So how can we rewrite this? I'm going to rewrite this 1 over, because there's nothing left. We cancel them out. We're leaving the shadow of all those t's, which is 1 over t squared. And so that leads us into our next definition here. Now, if we have a negative n, we're going to move it to the bottom. But now if the negative n is on top, it moves it to, if the negative n is on the bottom, it moves it to the top and becomes positive. Notice if it's negative n on top and you move it to the bottom of the fraction, it becomes a positive. And if it's on the bottom of the fraction, if the negative's on the bottom of the fraction, we move it to the top, it becomes positive. So now if we take a look at example 7, this t to the negative third is on the top, so we're going to move it to the bottom by putting 1 over t to the third, and now it comes 1 over t to the third because it was negative on top, but now it's positive on the bottom. Looking at 8, 12 over 60. Well, that will simplify to 1 over 5 because 12 goes into 12 once, and 12 goes into 60 5 times. Now we have b to the fourth minus 6. Well, I'm going to rewrite all of this as 1 over 5b to the negative second. Well, now we have b to the negative second on top, right? Now it's a negative exponent. What happens with a negative exponent on top? It moves to the bottom and becomes positive, so it's going to be 1 all over 5b to the second. Now jumping to number 9. Here we're going to combine a couple rules that we've been building on. Remember, this 2 is outside of the parentheses, so I'm going to have to take this 2 to that 2, so I'm going to have 6k to the negative fourth on the top and 4k to the negative second on the bottom. Now I'm going to simplify 6 to the fourth as 3 over 2, and now I have k to the negative fourth that I'm going to put down right here, but I'm going to subtract, right? I'm subtracting over a division bar, and I'm subtracting negative 2. Again, rewriting it as 3 all over 2, and now negative 4 minus a negative turns into a big fat positive. And so negative 4 plus 2 is still k to the negative second. What's a negative 2 on the top of the fraction do? It goes down to the bottom. So I'm going to have 3 all over 2k to the second for my final answer. Next, we're going to move on to something a little bit more. We're going to, again, with number 10, take this 2 to everything that is inside the parentheses. So we have 3 squared r squared s squared times s to the, remember when we have a exponent to an exponent, it's going to be s to the sixth t squared all over 12s squared t to the fourth. I'm going to write it again. I'm going to combine all of this stuff on top. Well, we have 3 squared is 9, r to the second, s to the eighth, t to the second, over. Then we have 12 still, s to the second, t to the fourth. Simplifying 9 and 12, that goes to 3 and 4. We have no r's on the bottom, so there's nothing to subtract from a r squared. Here we have 8 minus 2, so it's going to be s to the 6 on top, and then t squared minus this 4, so which on which side do we have more t's? We have more on the bottom, so it's going to be t squared on bottom, leaving it 3 r squared s to the 6 all over 4 times t to the second. So that leads us here. If we have this n outside of the parentheses, we are taking that n to everything that is inside the parentheses. We are taking it to the a, and we are taking it to the b. Now if it's negative, look what happens if it's negative. Go ahead and flip the fraction right away. It's negative exponent, flip the fraction, then take the n to both the numbers. So let's try another example here with number 11. We have the same 8 on top and bottom, so it's going to be 8, and then that's a bad looking 8, 3n from that variable minus, division means minus for exponents, 3n minus 2, and this needs to be in parentheses because it's the whole thing from down here. So it's 3n minus 3n. So those 3n's are going to cancel out, and then minus a negative 2 turns into a positive 2, so it's going to be 8 squared, or if you will, it is 64. Next one here, 12. All right, look, we have 3/4 to the negative third. What happens to that negative exponent? Let's go ahead and get rid of the negative exponent, so I'm going to rewrite it as 4/3 to the third. Now we can go ahead and reverse distribute. I guess it's kind of like distribute that 3 to the 4 and the 3, so it's 4 to the third all over 3 to the third. And remember, those are cubes, so it's going to be 4 times 4 times 4, which is 64 over 27. 3 times 3 times 3 gives us 27. And one more. Here we're using some scientific notation. Remember, this is a negative exponent here to everything here inside the parentheses. So I'm going to go 4.5 times 10 to the third, and negative exponents moves it to the bottom and becomes positive. So it's 7.5 times 10 to the second. Now 4.5 divided by 7.5 comes out to be a nice 0.6, and we have still times 10 to the, now we are 3 minus 2, so that leaves us times 10 to the first. But now it's not quite in scientific notation because we need one number to the left of the decimal. So we need one number to the left of the decimal. So there's my one number to the left, 6.0 times. Now, since we changed the decimal place, and I'm going to change my color too, since we changed the decimal place and moved it back to make it bigger, we have to take a exponent from our 10. So if we take 1 from 10, that gives us a 0, so it's 6.0 times 10 to the 0. And that concludes the lesson of dividing monomials.